Hello everyone, welcome to the class once again. I hope you're all doing good and in the best of your health. So after learning all the concepts of mechanical properties of solid, we have learned about Young's modulus, bulk modulus and Hooke's law and how to apply them. Now let's use these concepts in our NEET pattern exercise and what kind of questions do come in your NEET examination. Let's understand them. The questions are very simple, not too tough in your NEET pattern exercise. If you know the basic formula, if you know the basic concepts, you can easily solve the questions based upon the NEET pattern exercise, based upon the NEET examination that have been asked in your examination. Now the question that we're going to see today in our exercise that would be of moderate level of difficulty. Such questions have come previously in your examination and there are quite some questions which are probable to appear in examination. The kind of question that we're going to discuss today, they would be matching as per the NEET standards. Let's go ahead with the first question of the day. First question, a stress of 1 kg per square mm is applied on a wire. If the modulus of elasticity of the wire is 10 to power 10 dyne per square centimeter, then the percentage increase in the length of the wire will be A 0.0098%, B 0.98%, C 9.8% and D 98%. Now see, it's given that a stress of 1 kg per square mm. So the units used is, see the mass unit is in SI unit and the area unit is in square mm. That's two different units, but it doesn't matter. As far as we get the answer, it doesn't matter. If the modulus of elasticity of the wire is 10 to power 10 dyne per square centimeter, let me write down the specifications that has been given to us. It is given that the stress applied is 1 kg per square mm. 1 kg per square mm. This is what that has been given to us. Next you see, modulus of elasticity of the wire is 10 to power 10 dyne per square centimeter. Modulus of elasticity Y is equal to 10 to power 10 dyne per square centimeter. This is what that has been given to us. Percentage increase in the length of the wire will be, so understand what we require. Percentage increase in length of wire, we require delta L by L into 100%. This is what is required from us. We all know that Young's modulus is equal to stress upon strain. Strain is very simple, strain is only delta L by L. That is what we know about strain. So from here, if we try to find out the value of strain, that will come out to be stress divided by Young's modulus. Stress divided by Young's modulus, let me write that as Y. Now stress is 1 kg per square mm. Can we write this as 1 kg and square mm can convert it into centimeter? See what we are going to get. So if we write this as 1 kg divided by, now see, before going ahead with the 1 kg thing, can we write this in grams, 1000 grams? See why that would be helpful for us. Because dyne, while using the unit for Young's modulus as dyne, that would be in grams. So we can write stress as 1000 gram per square mm. So per square mm, what I'm going to do, instead of mm, I'm going to use 10 to power minus 1 because that will be converted into centimeter whole square. Next you see 10 to power 10 dyne. So let me use here 10 to power 10 dyne per square centimeter. And here also what unit that I am going to get? I am going to get gram per square centimeter. This is what I am going to get. Now clearly you can go ahead and you can simplify this. You can go ahead and you can simplify this. You will be getting the required result. Let's go ahead. And before that, you see stress is 1 kg per square mm. That is force per unit area is given as 1 kg. And one more thing, its mass given. And stress is in terms of, understand, stress in terms of weight we need to write down. So that's why we need to also multiply this 1 kg, this is the 1000 gram that I have written, with the proper value of gravitational constant extended to gravity, and that is not given, which we can use as 980. So let me use 980, the value, that's quite less space we have. Let me use here 980. I hope that you have got to know how we have done this. Now clearly only thing that we have to do, we have to use to simply solve the numerical value. For the numerical value. Now see here, let me cancel out some terms and let me reach to the final result. That will come out to be 3 zeros, and here I will be having minus 2. So that will come out to be, become 10 to power 5, and here you are having 980. So 980 into 10 to power 5 divided by, here you are having 10 to power 10. Clearly you can write this as 0.0098. 10 to power 5 will be left here, 3.0098, that is what you are going to get. That's the value of delta L by L. Delta L by L is this. So therefore, delta L by L multiplied with 100%, that will come out to be 0.98%. 0.98% is the answer. Let's check which option is matching. Clearly B, 0.98%, that's truly matching with the right answer. So let's go ahead with this answer. 0.98% we are getting as the result. I hope that you have understood how to solve such kind of question. Clearly you have to take the care of units. You have to take care of the units, what units you have to use in solving and what conversion you have to make. One more thing, the stress of 1 kg per square mm, its mass is given, you have to convert with proper weight, and weight you have to multiply with x due to gravity. With proper units you have to do so that you can get to the right result. Next thing, question number 2. To what depth below the surface of sea should a rubber ball be taken so as to decrease its volume by 0.1%? We have to decrease its volume by 0.1%. Given G equals to 10 meter per square second and the bulk modulus of rubber is 9 to 10 power 8 Newton per square meter. A 45 meter, B 90 meters, C 135 meter and D 180 centimeter. So it's given some units, some answer are in meter, some are answer in centimeter. Let's go ahead and let's check which option is matching with our right result. Now first of all, to what depth below surface of sea should a rubber ball be taken so as to decrease its volume by 0.1%? Decrease its volume by 0.1%, so delta V by V into 100% is given as 0.1%. We all know that bulk modulus, now it's decrease, so can we write this as minus? Not a problem. Bulk modulus is minus delta P by delta V by V, or we can use instead of delta P as pressure by this. So let me put here the value of pressure will come out to be minus, and you take this delta V by V here, delta V by V multiply by B. This is what you can do here. Now instead substitute the value of delta V by V, that will come out to be delta V by V will be equal to 0.001. That's quite obvious. Delta V by V will come out to be minus 0.001. So I'm going to put the value here, 0.001 multiplied with bulk modulus. The bulk modulus is given as 9 into 10 to power 8 Newton per square meter. 9 into 10 to power 8. So clearly, and again this delta V by V is also in negative, so let me use here minus sign here. So clearly this will come out to be 9 into 10 to power 5 will be the value of pressure, and that will be in Newton per square meter. That is what we have obtained. So what you do, take note till here, and let me start at the other end. Take note till here. Okay, I believe that you have understood how to find the value of pressure till at this end. Now let me write down, can we write this as H rho G is equal to value of pressure? Now clearly height will come out to be pressure upon rho G. Pressure is 9 into 10 to power 5. This is what we have obtained. Rho G. Rho, you see, the rho of water, because we have to check for the water, that will be 10 to power 3, and action due to gravity will be 10. So this will come out to be 4 zeros and 5 zeros, so 90 meters. 90 meter is the height that you have to take the rubber ball so that its volume decreases by 0.1%. So don't worry about this centimeter, this will be only in meters. So 90 meters will be the right answer. Rest you can just remove the centimeter part, it will be only in meters. Hope you have got how to solve such kind of question, and 90 meters is the depth that you have to take so that its volume decreases by 0.1%. This is a good question, and students get confused how to solve this. If you know the steps, if you know the method, you can easily solve such question. Let's go ahead with the next question of the day. Third, a wire can be broken by applying a load of 20 kg weight. The force required to break the wire of twice the diameter, same length and same material is A 5 kg weight, B 160 kg weight, C 80 kg weight, D 20 kg weight. Now in this case, you see here, a wire can be broken by applying a load of 20 kg weight. So first of all, you see the breaking stress if we talk about. This is the wire. It can be broken if you are applying a mass of 20 kg, it will be broken. Stress required to break in this case is 20 kg divided by the area. 20 kg weight, so divided by area. So can we write this as 20 g divided by area? This is breaking stress that is given. Now it says that the force required to break the wire of twice the diameter. So new stress will be new mass that you have to actually take here, and its required force you need to require. So with kg weight we need to find out. Let's say the mass hanging is mg divided by new area A dash. Breaking stress has to be equal, so both have to be equal. So can we write this as 20 g by A is equal to mg by A dash. Clearly g and g will be cancelled out. M will come out to be 20 A dash by A. New area, you see that diameter, same length and same material, but break the wire of twice the diameter. So 20, and area dash will be, because area is proportional to square of diameter, so let me write that twice the diameter, 2d whole square, and divide by this is d whole square. This will come out to be 80. That is, the new force required will be 80 kg weight. Hence, let's check the option. 5 kg weight incorrect, 160 kg weight incorrect, 80 kg weight, that's the correct answer. Rest all are incorrect. I hope that you have got to know how to solve such kind of question. Once again, first of all, you should know the breaking stress and equate the breaking stress to the new stress. That is what is required. So if you know that, you have to evaluate the value of mass. You have to evaluate the value of mass, that is what is required. Go ahead in this way and you will find that the answer that will come out to be the mass, that is 80 kg, and hence the breaking stress will be 80 kg weight. The breaking force will be 80 kg weight. Let's go ahead with the next question of the day. Question number 4. A force of 10 to power 6 Newton per square meter is required for breaking a material. Again, the breaking case is here. If the density of the material is 3 into 10 to power 3 kg per cubic meter, then the length of wire made of material so that it breaks under its own weight is G equals to 10 meter per square second, A 66.6 meter, B 60 meter, C 33.3 meter, and D 30 meter. A force of 10 to power 6 Newton per square meter is required for breaking a material. So the breaking stress, if we talk about, that is provided to us, breaking stress, and that is given to us, you see here, 10 to power 6 Newton per square meter. 10 to power 6 Newton per square meter, that is what has been given to us. If the density of the material is 3 into 10 power 3 kg per cubic meter, density of material 3 into 10 to power 3 kg per cubic meter is provided to us. Next, then the length of wire made of material so that it breaks under its own weight. So not too tough for us to understand. See here, this is the wire. Let's say its length is given as L clearly if I talk about its mass will be given as density into volume, so area into length. Mass will be density into volume, so rho into A into L, where A is the area of cross section. Now see that we have to think about, it has to break under its own weight. The maximum stress would be acting at the topmost point, because the entire weight would be actually pulling the topmost point. So here the maximum stress would be acting. So that's why I have taken full length of the wire. Now you see here, the stress due to its own weight will come out to be mg by A, and equate this to 10 to power 6 Newton per square meter. So we can easily find out the value of maximum length. So if I write this as 10 to power 6 is equal to mg by A, m is given as rho into A into L divided by A, and g also 10 to power 6. So finally length we want, length will come out to be, that will be equal to 10 to power 6 divided by rho into g, hence 10 to power 6. And since all the values that I am going to put that are in SI units, so I need not to worry about putting the units here, that will automatically be taken care of. Rho is given as density, that is given as 3 to 10 power 3 multiply with g 10. This will come out to be 100 by 3. This will come out to be 100 by 3, that is 33.33 meter. 33.3. If you take a wire of 33.33 meter, it's going to break under its own weight. Option number A, 66.6 meter, incorrect. 60 meter incorrect, and 33.3 meter, that's the correct answer. Rest all are incorrect. I hope you have got to know how to do this question. Quite useful for us to understand for the case of breaking stress, under what condition it's going to break due to its own weight. So have you ever imagined that if you go on taking a wire and if you hang it, it might break due to its own weight only. And learning this chapter is quite interesting, because you know that in your we use cranes to lift heavy loads. And that's why we find that we should know that under what condition it will break, the wires will break. So for that reason we require to learn this chapter. And when you go and study in mechanical engineering, you will be taught strength of materials. That will be a part of this one. And an elaborately you will be taught about this concept. Very interesting thing. Let's go with the fifth question of the day. If a metal wire is stretched a little beyond its elastic limit, you have taken a metal wire, it's stretched a little beyond its elastic limit or yield point and released. It will A, not contract, B, lose its elastic property completely, C, contract only up to its length at the elastic limit, D, contract but its final length will be greater than its initial length. For this case, I have taught you about the stress strain curve. What happens? See, if you remember the stress strain curve that we have learnt in this chapter, I have discussed that initially it's going to obey the elastic limit and it's going to go ahead in this way. This is the yield point. This is the elastic limit. Till here what happens? Elastic limits means what? Where stress will be proportional to strain. Here we have taken strain and here we have taken stress. But if you give more strain and if you leave it, a permanent, although it's going to regain, but a permanent strain will be left. If you remove the stress, a permanent strain will be left. This is what we know. So we have to check in this area as per the given question. You see here, if a metal wire is stretched a little beyond its elastic limit or yield point and released, it will A, not contract. No, it's going to contract. It's going to reach. Incorrect. Lose its elastic property completely? No, it's not losing its elastic property completely, because still it's trying to regain its original shape and size. It's trying, the resilience property is still maintained. No. Contract only up to its length at the elastic limit. We see that if the weight stress is removed, it's going to reach here, permanent strain is there. It's not only going to contract till this end. No. So C will be incorrect. D, contract, but its final length will be greater than its initial length. Yes, its final length will be greater than initial length because this is a permanent strain which comes. That means there will be an extension in the length. There will be an extension in the length. So hence there will be, the length will be more than the initial length. That is what we can make out from this option number D. Clearly option number D is the right answer. Not to comment more upon this. And if you have listened to this class with all your attention, you would be remembering this curve that I have drawn: elastic limit, plastic limit, then again breaking point when the wire becomes ductile, all those things we have discussed. So if you remember that, if you have seen that class, you can clearly identify from this curve that option number D is the right answer. So with all these 5 questions, I hope that your learning will be quite enhanced and you have understood how to apply the basic formulae in questions in your NEET examination. In your NEET examination, the questions the level of difficulty will be quite moderate. Not simple question will not come, not too tough question will be coming. But remember that in less time you have to do 45 questions in physics. So here the trick is that you have to have more accuracy and with speed. That will come with practice, and if you know the basic concepts, you can answer every question of your physics examination. Physics part of your NEET examination. So that is, we are having the first exercise, the first 5 questions. In the next exercise, I'll be taking care of the next 5 questions. Hope that you are enjoying learning with me physics and you are entailing your concepts in a more better way in your mind. Do practice question after the class also. Do see unsolved examples, unsolved question in your textbook. That will be of great help to you all. So thank you everyone for joining me. I'll meet you all in the next class. Thank you everyone.